Great, thanks. Ooh, oh, it's even up already. Wow, awesome. Yeah, thanks a lot. So I guess this is going to be a little bit different than most of the rest of today. I'm going to be talking about motion design with CSS, obviously, which is a thing that I think we all need to learn and know a lot about as we move forward with the web. So I'm Val Head. I'm the design director at a small web design shop in Pittsburgh, which is not close to here. And I also specialize in teaching people about web animation, and I do a lot of training and a lot of talking about it. And I'm really excited about where web animation is at right now. Like, we have the ability in websites and web apps and web anything to create animation that's like true to the web, that's performant, that's accessible, that can be progressively enhanced, and all this stuff that like no other medium out there can do except for us. So we're clearly better. But as the web's moving forward, the people that are using the stuff that we build, that we design and we build, and our audiences are starting to demand a different kind of interaction. For them, the idea of having things that are animated is just like kind of baseline. It's what they expect. The static, page to page, state to state with just hard cuts that the web used to always do isn't really good enough anymore. So that's why no matter what your role is, this is important stuff. At least I think it's important stuff to understand. So I think we should actually have more animation on the web, which is sometimes an unpopular opinion, because a lot of people think that more animation on the web means we're going to have an entire internet of this kind of animation. If you're wondering what I'm doing while I'm recording this, I'm scrolling down, which totally does not explain why there's things flying in from the left and right, and I sort of have no idea what's going on. And then you get to do it all again when you scroll up. So more animation on the web could mean that, but it doesn't have to, because more animation on the web can also mean things like this, which is Stripe checkout, which you've probably run into at some point in time. And there's a lot of animation that they use throughout this entire checkout process. If you counted them all, there'd be a lot. But the main difference between Stripe's animation or use of animation and GoChat's use of animation isn't really the number of animations. It's more to do with where they are and how they were placed. Basically, Stripe's animation when they put them in there, they knew why those animations were there. They weren't just there to fly stuff around. It was to give useful feedback, to let you know you've made a mistake, to let you know something has changed, that kind of thing. And they went through a lot of effort to design them in a way that also looked good. So the good kind of animation, the kind of animation we want more of and we should be making more of, is the kind of animation that has a known purpose and a really good style. They're kind of the two halves of the puzzle, right? Even if you have an animation that you're like, this animation is going to give everyone really good feedback as to the things they just reordered in their cart. It's great, and it has this really defined purpose. But if it's also ugly or slow or chunky or whatever, you've just completely negated your purpose. You had a purpose, and then you just kind of undid it by not making it look good. So I'm going to be talking today about making it look good, obviously. That's the motion design part. Because as people who work on the web, we generally don't know much about motion design. We've never had to, right? Sometimes at workshops, I do a poll to see how many people in the room have a motion design degree. One time, there was one guy in a room of 30 web designers who had motion design experience. So it's just not a thing we know. But it's actually something we can fake really well. We don't have to go through a crazy university degree to be able to design motion that looks good and that behaves well. It's not really that hard. So animating with style is what we are aiming to do. And basically to do that, we kind of have to look at the classic motion design principles and classic motion design theories. Which maybe sounds like a lot, but it's not so bad. And the main reason we want to do it is, one, so we make motion that's better, because we want the animation on the web to be just as good as any other animation, because I just decided we were better than everyone else a minute ago. But also, it helps us have a vocabulary to describe animation. I don't know if you've ever been on a project with a colleague, and you're like, oh, I just want that button to have more oomph. And everyone's like, that's not a word. That doesn't mean anything. What are you talking about? And you and whoever you're working with have a totally different idea of what oomph means. And it becomes really difficult to talk about. So learning these gives us a better vocabulary as well. So when we look at the classic principles of animation, they're pretty much all done by a little company called Disney. You may have heard of them. This is actually a really amazing book. It's like super thick. It smells like old library. I don't know yeah, it's one of those paper book things, and it just smells like oldness. It's great. So much good information in it. And conveniently, it's also very well summarized in this Tumblr, which is only half a joke because it really is a good summary of that book. Like the parts of the book that are most useful to us as people who work in digital things and interfaces are really well summarized in that Tumblr. If you don't have time for a Tumblr, there's also like a 5-minute Vimeo version of it. So no matter what, it's pretty good to review. And the main reason we would care about any of this is because we want to create animation that feels a little bit real, right? Like, if you create animation that kind of echoes the real world that we all exist in, that has like gravity and like resistance and drag and all that stuff, if your interface can just kind of call to that a little bit, even if it's not perfectly replicated, it feels more familiar and it makes more sense. And people are just kind of like, all right, I can handle that. It's a little more pleasant. So in that book, we have the 12 principles of animation, which you probably heard of before. And I mean, it's really hard to read an article or a book about animation anymore that doesn't mention these. And there's plenty of posts and articles that are all about like how to do the 12 principles in CSS, which are all great. But 12 is like a long list. I'm kind of lazy, and really we don't, well, those sort of two separate points. But all 12 aren't equally important to us working on like screens with these fancy computers to do all our work for us, or not all of it, but some of it. You know, these were written by a bunch of guys in like the 30s to 80s who were hand drawing characters on like, you know, layers of cell paper and shooting it with a crazy camera setup. And they had like interns to do all the like grunt work and do all the in-betweens. But we have computers and we're making interfaces, so our goals aren't quite the same. In fact, I think that basically taking like 3 of them, if you take these 3, which I'm going to go through in a second, you can make your animation probably better than like 90% of what's already on the web, even just doing like a quarter of these 12. They're all super interesting to know about, but just not equally, as in not all of equal importance to us. So to illustrate how we can make an animation better by just using 3 of these, I put together a little example for us. It's a really simple one, basically just a modal window. This particular one is confirming our reservation at a cat cafe, which are actually real things, believe it or not. Who knew? So it's like, we'll play that again. It's just kind of there. Like our starting point is like, you wanted it to animate in, so I animated it in. I'm done. And that's kind of the point we're at. But we could do so much more with this to just make it actually be designed as opposed to just there. You know, this is the point where we're basically like transition in, go. We can do better than that. Oh, so here's what's going on under the hood. There's some animation. I'm showing this all in CSS, but it really applies to any other method you're using for web animation. I don't know if you've noticed, but we have like 500 ways to make things move on the web. It's a little crazy. They're all pretty cool. But CSS is kind of like the lowest common denominator. Like if CSS can do motion design, holy crap, everything else can too. So we've got a couple animations running our main box. We're just kind of sliding them in, and we're fading them in. I'm using these animations really modularly. Wow, that one went green. And kind of piling them on top of each other. I like to do that because it just makes it easier to mix them together. If you take short animations, pile them together, as opposed to writing a really long animation, and then when you go to edit it, you kind of want to stab your past self. So that's the slide-in animation. That's running our little box guy there. And we also have this fade-in animation as well. Slide down is only being used by the button right now, because that's our little modal window went in, our button came back out. We're going to make that better too. So we'll start with, which is one that's probably the most important principle of animation, which is timing and spacing. Interestingly enough, in the Disney book, they only call it timing, but it's really timing and spacing. And these are kind of, well, they really are the most important principles of animation. Like if you learned nothing else about animation, but you knew timing and spacing, you're doing in really good shape. And they're also the hardest ones to do well, because they're kind of more of an art than a science, which is sometimes super annoying, but the more you do it, the better you get at it. So it works out. So timing is basically the duration of an animation, which is how long it takes for an action to complete, basically. Kind of self-explanatory, makes a lot of sense. And the main way people, or the classic way of explaining timing is with a bouncing ball. And I figure if it's good enough for Disney, it's good enough for me. So I made you a bouncing ball example. This is going to be amazing. Yeah, kind of looks like a bouncing ball. Yeah, you all seem very impressed. It's good. So the timing of that bouncing ball, we can actually mark it as we go. So this is the path the ball takes. It's going to bounce, gets a little lower each time. And if we mark the timing, it would look like this. So our timing is actually like that dun, 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 dun. That's the timing of our animation. They get a little closer together because the ball is losing speed, because like gravity. And each movement, each bounce, is its own action. And that's our timing. Pretty easy. Spacing is super related, and it totally makes sense why these are kind of together in one principle or one concept. And spacing is really the change in the speed of an animation over time. It gets its name from the classic animation style of drawing frame by frame, because when you're drawing frame by frame and you have a constant frame rate, how far apart you make those drawings affects the speed of the animation. So if you make drawing 1 here and drawing 2 there, that's going to go really fast, and if they're very close together, from one frame to the next, it'll move very slow. Thankfully, we don't have to draw frame-by-frame animation unless we want to, and the computer does all that for us, which is awesome. So if we mark the spacing on our same bouncing ball, it would basically be, the way we do that is take kind of like a freeze frame of each individual frame of this action. So it would look like that. And you can see the different spacing we get where when the ball is falling, they're spaced further apart because it's going faster. And then it gets to the top of those arcs when it's like, oh man, gravity, oh, I can't go very high. It gets closer together and slows down, and then gets pulled down faster again. And each time it's a little lower, a little slower, and then it just stops bouncing. It's the most dramatic enactment of a bouncing ball you've ever had, isn't it? Yeah, thought so. But that's where we get spacing from. And it's just, that's where the definition comes from, even though we don't work that way. So timing and spacing do two really important things, and this is the reason we would look at bouncing balls in excruciating detail. They make objects appear to obey the law of physics. Kind of a good thing. We're all really used to stuff like gravity. It's pretty nice when our interfaces at least reference that. But more importantly for us is it establishes a mood and just like the reaction. When things move, when we see stuff move in front of us, even if it's something that's like a button and clearly not a human being, we start thinking in our minds like, why is that moving? Why did it go that way? And we assign personality to it, whether you want to or not. It's kind of crazy. Brains are really crazy, but we do that. So if we control that by affecting our timing and spacing intentionally, you can convey an extra message to anyone using your interface. If you just kind of leave it at whatever it is, you just sort of pass that up. So for us, timing is duration and spacing is easing. Easing is what changes the speed over time of an animation, and basically the thing that draws all the frames for us, so we don't have to. Thank goodness for easing. Oh my goodness. Of course, we just said that spacing is really important for creating mood and emotion and replicating physics, and then you look at CSS and you're like, we have 5 easing keywords. How are we supposed to be expressive with that? 5 is not very many. And technically, linear is just basically super mechanical movement that starts and ends at the exact same speed, which nothing in the physical world can do. So you're kind of down to 4. And then if you want to be really nerdy about it, which I do because I'm nerdy about animation, ease and Easeout are really similar. Ease is just kind of a crappy version of that, so we're down to 3. And you're like, that's not... Yeah, we can't do motion design with 3 options. That's crap. So thankfully, we have our friend, the cubic Bezier function, or as I like to refer to him when I first was introduced to the cubic Bezier function, number barf. Because no one really looks at anything and is like, you know what that needs? I think it needs more of a 0.50. Yeah, it's not a 0.42. We need a little more higher numbers. No one thinks of motion like this. But if you're super into graphing or data, when you see 4 numbers, you're probably like, hey, it's XY coordinates. Duh. Which is exactly what it is. All of my data friends, that's what they see when they see 4 numbers. They're like, XY coordinates. It's 2 of them. Let's plot them on a graph. So let's plot them on a graph. So this is a motion graph, which is a lot easier to read, especially very quickly when you want to choose easing or interpret easing in a way that you can talk about. And we tend to use these a lot more. So the two XY coordinates are this guy and that one. So it's very much like Illustrator or any other type of Bezier situation where you have, our beginning and end points are fixed because the animation has to start, just kind of a thing, and it also does have to end. We can get into the metaphysical discussions of why that's necessary some other time, but it has to start and it has to end. So those 2 points are fixed. But what we can do is drag those little control handles to change the shape of the curve, and that's what gives us different kinds of easing with cubic Bezier easing. Where the curve is steeper, we're going faster, and where it's flatter, we're going slower, or it's a slower rate of change. So this one obviously starts slow, goes fastest in the middle, and then slows down again at the end. It's a perfect ease in out. Well, it actually is ease in out. And to do really good motion design on the web, we want to be working with these more than we work with keywords, whether that's in CSS specifically or in your JavaScript animation library. Pretty much all of them give you these keywords, these defaults, and then they also let you go in and make your own. We should all totally be making our own graphs. Because all the other people that call themselves motion designers in this world, well, that's kind of dramatic, but whatever, they would never release a project without going into their graph view. And I mean, our graph view looks a lot easier than this. Who knows what that even is? Actually, I do know what that is, but that's OK. They wouldn't let something out the door if they hadn't adjusted each particular point of easing in each particular frame. So we probably shouldn't either. A really good place to mess around with cubic Bezier functions is conveniently cubicbezier.com, a site Leo Veru put together a while ago, actually. But it's still my favorite one. So you can go there and mess around with the control points and change the curve, compare it to other ones. And then when you've got one you like, you can race it against other easing curves. Spoiler alert, though, it's always a tie. Timing is king, sorry. If you prefer things that are a little bit more pre-baked, there's also things like easings.net, which has a bunch of curves predefined and also has the CSS equivalent of the Penner easing equations. So if you've done any Flash stuff or basically any other programmatic animation ever in the last decade, you've probably used the Penner easing equations. And yes, that's a pretty helpful place to get that. So basically, the moral of the story is everything is better with cubic Beziers. Ice cream, pizza, whatever, things. So in true cooking show style, I've selected this easing curve to make our modal box behave or animate a little bit better. I messed around with some curves or some control points, and I very specifically got a curve that went outside of the box. That's important. So I took that cubic Bezier function and pasted it into my CSS. Yeah. Never saw that coming, did you? Didn't think so. And then once we have that there, that's basically all the changes we made. And then when we check out what we've got, it looks more like this. Oh, wait, sorry. Let me do that again. This is what we had, right? Just kind of here's your reservation. And now we have this with our cubic Bezier function change. So it's got a little bit more energy already, right? We'll do that again, because I know it goes really fast. But now instead of just being your reservation, it's your reservation is here. And it's got a little more energy. We actually didn't adjust the duration at all, but it feels like it's moving a little faster. So conveniently, by picking that cubic Bezier function, I've actually implemented a second principle of animation, a second classic principle, which is follow-through. It's generally classically shown by this bulldog with his crazy big floppy bulldog cheeks. And follow-through is essentially the idea that not everything comes to a stop at once. And it makes a lot of sense. And if you look at the bulldog drawing, you can see he turns his head and his cheeks follow slower, and then they're blub, 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 and then they finally stop. So follow-through is things like wobbly bulldog cheeks. You never thought you'd hear anyone say that. And it's also things that it's just things not stopping at once. It's not a particular fluid type of thing, because the Roadrunner also has follow-through, but it's much stiffer. And he's just he doesn't have floppy cheeks. He's I just had to stop because there's birdseed, wow. And for us, when it comes to animating things that aren't characters, follow-through is often just overshooting the target position, which is what we just did. It's you have so much energy, you just can't stop in time, and it gives that energy of overshooting and kind of a little bit of a bounce. So that's pretty good. We achieve follow-through by using our curve that popped out at the top, and then I have it in here again in case you missed it, just in case we had to see it like 4 times. So secondary action is our third principle of animation that we can apply to this to make it just a little bit more organic. Because we added a little bit more energy with the follow-through, which was also our spacing. It's kind of interesting how that works. You're like, spacing and follow-through, totally related. And I think we can do just one thing that's a little bit better. On the internet, especially on the web, less so in apps, but very much so on the web, we tend to treat everything like it's a slideshow and everything is attached, right? Like if you imagine a recent carousel you've seen online, it's like the first thing slides in, it's like, here I am, and it's like a photo with text and a button, and then like the whole thing goes out, and then number 2 comes in, and it's the same stuff, and it all moves like the text and the button are attached to the photo, but like, why? They don't have to be. We can make things move not all at the same time, not like they're etched in glass. So secondary action is any supplemental action that adds dimension, really, to the main action, which is using action a lot in one sentence, but that's OK, and it's kind of what it sounds like it would be. So to add some secondary action in, there's a couple things we're going to do. I'm going to play a video of it since we don't have a ton of time. I'm going to create a second animation for sliding in and make it just a little bit shorter. Because what I want to do is have the text in my box move at a slightly different rate than its parent element. I'm going to take that shorter animation and apply it to my text, starting with my H2 and H3. Because I figure that they should probably move up, the paragraph should move up, and then they'll all settle down. It'll be like very organic and kind of wavy. So I'll assign that animation. It's going to take 0.3 seconds, and I'm going to delay it just a little bit. Global delay is just a thing, so this demo will, not start immediately. We'll delay it by a tiny bit, give it a custom ease. Sass variables are awesome for saving your custom easing. I love them. And we'll give it a fill mode of both. Then we'll apply our second animation, which is the same second animation that our section has up there. So we're giving our child elements a very similar motion to our parent element. Same delay, yay. Watching people type delay is pretty fun. And then we're going to give that another custom easing as well, as soon as I manage to type it out. So we're giving our H2 and H3 just a slightly shorter and slightly delayed version of the same animation our parent is doing. And then to give it more of a wave, we'll apply it to our paragraph too. So we'll have our box moving up, and before that's done, we'll have our title and then our paragraph, and then they'll all settle down together. And of course, there's a little bit of work in getting that timing right, so that way they start right when the main box is going up too. So, I don't have the video of that, do I? Well, that was very silly of me. So then our final piece will look like this. So we've just got that little bit more of an organic wave to it, where the box went up, and our text, our heading and our paragraph went up, and they all went down together. So they kind of follow just slightly delayed, which also conveniently gives us a really nice line of sight down to our button, where we kind of have this whole up and down. So we've made our motion more organic, given it more energy, and also made kind of like something to guide your eye to your Make Another Reservation button, which is pretty cool. It's a lot better than what we started with. And interestingly enough, we didn't make anything longer. It didn't take more time. And really just kind of going through that little checklist of where can we add secondary action? Do we want more energy? Let's do that with follow-through. Let's consider our easing. It really doesn't take that long. When we just did it all together on stage in like 20 minutes, and you can probably do it a lot faster if you don't have to like say it out loud while you're doing it. One other thing about timing, because we should always go back to timing once we've designed the motion that we want. We've got this box behaving like we want it to. It's saying what we want it to say with its motion. It feels organic. It's got energy. But chances are it's probably a little too slow. Most animations on the web, especially UI animations, are a bit too slow. I don't think that's necessarily because we suck at it or anything. I think it's because it's new to us, for one thing. And also, when you're designing something, you're like staring at it and obsessing over it because you want to see every little motion. And like, I want to make sure my paragraph doesn't start till my box is like almost all the way up. And we just get so used to wanting to see all those details. We need it to be really slow. But of course, it takes a lot less time to read an animation than it does to design it. So someone can see the thing that we designed and get all that same information about the energy and the feel, and it takes them like 3/4 of the time it takes us. So you want to be a little careful about how long you make your animations, and always go back and speed them up a little bit. People really love absolute numbers for this, but sorry, there's no such thing. It's more of an art than a science. So I have a range instead. Something between 0.2 and 0.5 seconds is a really good range for animations, for UI animations. Things like button fades are probably more along the 0.2, and then something like, modal windows moving a great distance, or anything moving a great distance, is closer to your 0.5. You want to make sure that whatever duration your animation has, it's fast enough, it's short enough that it feels like it's happening quickly and it's responding to you, but you also want it to be slow enough that you can see something happened. Because if it's so fast you can't see it, why did you animate it? And complex easing needs to be a little bit longer. We saw this a little bit with our box. When we added the follow-through, it felt like it was going faster, even though all we did was just change our easing curve. That gets multiplied and magnified a lot if you're using bounce easing. If you have a thing that's like bounce, 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 that's going to take up, each one of those bounces takes up a little time for it to register and for you to see it, so you might need a longer duration for that. Technically, according to research, and I think this is hilarious, we have between 0.1 seconds and 1 entire second to make feedback feel related. This is according to the Nielsen group, Jacob Nielsen. He says that the time between knowing that you clicked a button and seeing the result of that, you can take up to 1 second. Maybe in a lab, but can you imagine if all of your feedback took 1 second? People would be like, I hate this app, it sucks. So definitely you want to be more than take longer than 0.1 second, because anything lower than that feels instant, and we don't see it. 1 second is probably a little bit much, but it's an interesting research. And the sort of timeline you want to think about is the idea that hey, you touch or click something. We have about 100 milliseconds, that 0.1 second, for people to realize that something is happening and for them to get that. Then we have our 200 to 500 milliseconds of the animation doing its thing. And there's also a little delay at the end, where it takes people a fraction of a second to basically kind of absorb what happened and be ready to take the next action. For most people, it's around 100 milliseconds, maybe a little shorter. But research has shown that for some people, it could be up to 700 milliseconds, which is almost an entire second for that to be processed and be realized. So it gets very nuanced, and this is the reason you really want to prototype and test your animations and see how they feel and look, because it's a little bit too much and too involved to be super everything's 0.3 seconds or else. So good tips for timing is to focus on how the animation feels, and really prototype and iterate. And the only kind of actual solid rule I have is that ease-outs tend to be better for animated interactions. And that's mostly because ease-outs start fast and slow down, right? They're like, hello, I'm your button, what do you want? And if you use an ease-in, it's kind of it just starts slow and sometimes feels like it's not actually responding to you. It's really fun to act out. You should totally do it in meetings. At least that's what I think. So that's my rundown, basically, of things you need to do to get started and feeling like a motion designer, and just make these things that we animate feel a little better, be designed, and really say what you want them to say. Because that's the key. It's just taking advantage of that opportunity to communicate. Oops. Sorry, another keynote issue. So that's pretty much it for animating with motion design and getting that into your CSS. I hope you guys thought it was fun. If you're interested in learning more about web animation and all of this stuff, I have a little newsletter I send out every couple weeks and babble on about these things. You can find me on Twitter if you want to talk about any of this, and we'll probably all hang out for a little bit. But yeah, that's pretty much it. Thanks so much for listening.
I'm wondering, did you hear about GSAP, a green stack animation platform, and what do you think about that?
I think it's pretty awesome. I especially love it for SVG, for animating SVG, because holy crap, that's a nightmare without something helpful like GSAP.
And I think the CSS animation doesn't give you that much control over the timeline like GSAP does. And it really sucks to write those delays that you did on the presentation.
Yeah, I mean, most of those delays were there for the sake of making this play well for animation. For a presentation. But it kind of gives us that whole spectrum of things that are available to us, right? If you need just a tiny bit of animation, just a little bit. CSS is perfect, like you're probably already using it. But kind of once you get past like maybe 3 or 4 animations, especially if they need to be related, that's when something like green sock makes so much more sense. Or if you're like really into it, you can write your own thing that goes through request animation frame. But I like using stuff like green sock because they've figured out all the hard stuff. And then I can just animate things. But yeah, it's an interesting spectrum, and there is a lot of overlap of like things you could do with CSS, but maybe it's smarter to go with JavaScript. So I don't know, I like having those options.
I don't have a real question. I think the 1 second limit you mentioned, I think it's about the difference between user action and reaction, and up to 1 second can believe for example, loading more data, and then it still fits into patience of an user.
Yeah, I think it's really interesting that they tried to find that upper limit and just see how long you could actually, like, how big of a gap you can have. Super interesting for research, but like, you know, we definitely want things to be faster.